Alright, in this video I'm going to just do two very quick little proofs that involve isosceles triangles and show you how it can come in handy with that. So again, we're just doing two column proofs. So you set up your two columns with your statements and your reasons. And you always start, number one is always your given information. Now look at their given information. They're telling us that this triangle is isosceles, and then by identifying the base, then we know some other information. I'm going to do the given there. The other piece of given information is that MT, the perpendicular bisector of AH. So all of that's in the given. So what conclusion can we make if, so the whole AMH, the whole triangle, is isosceles if AH is the base? The conclusion we can, one conclusion, we can make two conclusions. Then angle A must be congruent to angle H because base angles of an isosceles triangle are congruent. So we can make that conclusion. Okay. Then the other conclusion we can make from there is, for statement 3, is that segment AM must be congruent to segment MH. So that's this one and this one. Because in any given triangle, this is what I showed you in the previous video, if two angles are congruent, then the sides opposite those two angles are congruent. So, or you might just see definition of an isosceles triangle. Okay. Now we're trying to get the two little half triangles are congruent there. So we need this perpendicular bisector. Really, it's that bisector that we need there. So if MT bisects AH, then again, the bisector is separates it into two equal pieces, and so AT has to be congruent to TH, and that would be definition of a bisector. Now look at the picture. You should be able to look at the picture and know where we're going from here. And because if we look at what our markings are showing there, we should see some side angle side on these two triangles. You get the blue side, the green angle, the red side. So triangle MAT is congruent to triangle MHT. Okay, so just the way you can use isosceles in there to kind of shorten things up a little, but base angles must be congruent, and then if the two angles are congruent, the two sides are congruent. Okay, so one more, very similar to the last one, just looking at things, given information. Always set up your two columns. We always know the first one is going to be whatever information they gave us to start with. BD bisects, there's that word again, angle ABC. That tells me that if I'm cutting an angle in half, I should have another statement where I'm going to have an angle congruent to an angle, because that's what a bisector does. I'm kind of thinking, even without looking at the picture, give me a bisector. So this one down the middle here bisects angle ABC. So we cut an angle in half, we're going to have two angles congruent. Now they were nice here and labeled our angles. Well, angle 1 is going to be congruent to angle 2 because that angle got cut in half. Okay. Now they're just trying to prove here that that the whole big triangle is isosceles. So if we can, we'll work our way to that here, just keeping in mind. Okay, so perpendicular gives us that angle 3 and angle 4 must be right angles. So that's what perpendicular means. Okay, so definition of perpendicular. So these are right angles. And yeah, you'll see it a little bit differently in textbooks from one to another, but then again, it's kind of definition of right angles, but then all right angles are congruent. So I don't know why they make us do 2 statements there, but sometimes they want 2 statements there. And then you may see books that skip that and skip number 3 and just say that, you know, they're right angles and they're congruent. And now we've got that shared side. So if I say that DB is congruent to DB, remember, when something's congruent to itself, we use reflexive property. Okay, and then now with what I've got, we can look at that picture and we should be able to see the angle side angle over there. So we got angle side angle in our picture. Okay. Well, so if we use angle side angle, it's some triangle is congruent to some triangle. So if I do the top, if I do A, B, D, it's going to be C, B, D to do the right, to get things in the right order. No, that's not what they told, not what we're looking for yet. So if those 2 triangles are congruent, then angle A must be congruent to angle C because it's the first one in each there. I'll mark it over here. That would be our corresponding parts of congruent triangles are congruent. Now, for our whole triangle, if A and C are congruent, I've got base angles congruent, which means it's an isosceles triangle. So triangle ABC is isosceles. I should be able to say that now, which is, whoops, I didn't go back to pen. There we go. Triangle ABC is isosceles because we've got base angles congruent. So the fact that we knew it was isosceles helped us with that. Okay, so that's the rest of the isosceles stuff, so the proofs with isosceles triangles.